The first question we'll be looking at is evaluate sine 3x dx. It's here say evaluate the integral value of sine 3x with respect to what? To x. Now we are not going to look at go very far in thinking about this, but remember when you are asked to integrate, integration is more like the reverse of differentiation. So when you differentiate something, you can reverse it back with what? With integration. Now when you are given a value x raised to power n and you are asked to differentiate x raised to power n with respect to what? To x. All you need to do is to use this general formula n plus 1 all over n plus 1 c. That is what your result will give you. So all you need to do is to add 1 to this and divide it by what? By the total value of this. That is why we say integration is the reverse of what? Of differentiation. Because on the other hand, differentiation, you do the other thing the other way around. If you are asked to differentiate this value with respect to x, you have your x raised to power n. You have to differentiate this value with respect to x. What this is going to give you is what? Your n this raised to power n minus 1, and that is exactly what you are going to. All you have to do is to subtract 1 from this value and then multiply the constant, the value by the what? By the constant. That is just all you need to do. So you see that this one we are subtracting, when reversing it back we will add what? The 1, and that is why we say integration is the reverse of what? Of differentiation. Now I'm going to give you a full-blown video on differentiation and integration. These are just facets of a video that you're going to see some few questions that can help you solve integration meanwhile. Now let's go straight to this question. Now this question has to, by the way, this question has to do with you integrating sine of this value with respect to what? To x. Now what do we need to do in this instance? If we are given a question in this instance, the best way to solve this question is to break it down. Now in this question, we will assume, we will let our words, let u be the value 3x. Now if we let our u to be equal to x, we are going to find the du dx of that what value 3x. Now if we are looking for the du dx of this value, I want you to note 3 things. If you are differentiating a constant, you get 0. If you are differentiating a value for x, you get what? You get a constant. And that is how differentiation goes. Now if we differentiate this, the y, we will look for the differentiate this with respect to x, we are going to have our result to be what? To be 3. So that means our du dx will be equal to what? 3. Now if our du dx is equal to 3, this will be equal to what? 3. If our du dx is equal to 3, that means if we cross multiply this, we are going to have 3 dx equal to what? Du. So that means our dx will be equal to what? Du over what? 3, which is still equal to 1 over 3 d what? Du. Now take notes that we found 2 things by separating this equation. 1, we've come to see that we have a value that is replacing 3x, and we've come to see that we have another value that is replacing what? Dx. We have our dx, we'll have our what? We'll have our x. So having done this, all we now need to do is to input this value into this for 3x, and then input this value of dx replacing this. Now we'll go back to our question. Now we are going to have 1 over 3 because it's a constant. Differentiating, we'll have our sine what? we'll have our sign 3x now is now being represented with u, and what? And the x is represented with what? The what? U. Remember, the 1 over 3 is now out. So what we are left with now is to integrate sine u with respect to what? With u. Now, if we are looking for the integral of a value, remember the derivative of sine. If we are asked to integrate sine x, the derivative, the answer will be cos of what? Cos minus of cos of x plus what? Plus c. That is why I told you it's going to be like a bonus for you. At the end of this video, you are going to see bonus, and that bonus is going to be videos of all the integral derivative of everything you need, so long as integration is concerned. Look forward to those derivatives. So if you do this, you are going to have minus of cos x plus c. So if we are doing this, we are going to have 1 over 3 multiplied by minus of what? Cos what? U plus what? Plus the constant c. So if we simplify this, we are going to have our 1 over 3, that is minus of 1 over 3 minus of 1 over 3 cos what? Cos u plus what? C. That is the solution you are going to have. So we can simply replace our what? Our u with 3s, and at the end our solution will be what? Minus 1 over 3 cos of what? 3x plus what? Plus constants. Now you see how gradually we broke this out parts to finally get what? Our solution. Now when you are given a question like this, all you need to do, just as we have done, is separate this, treat it as a whole, get the value of what? Of your dx, so that you can input it here and get this value, input it here, and then you make the equation simpler for you to to evaluate. Now look forward to the next question. Let's look at another way a question in integration can come, and let's see how we can solve it. Let's look at the next question. Way you can also see your question in integration, and the question says evaluate the integral value of x squared minus 4x with respect to what? To x. Now this kind of integration solution question has the upper limit and the what? And the lower limit. That means when you are integrating, your integration must be within those two units. Now how can we apply this in solving this question? Remember, this is the question where we now need to apply the formula for integration. Remember, I told you earlier on that the general formula for integration, if you are asked to integrate this with respect to what? With respect to x, all you need to do is this will give you what? This will give you your x n plus what? 1 all over what? N plus 1 plus what? The constant c, which is the constant of integration. Now if you are given that we want to integrate this, we have our value. We are integrating x squared in this limit, within this limit, x squared minus what? 4x with respect to what? With respect to s. So this is going to give us, if we integrate this, we are going to have our x raised to power 2 plus what? 1 all over what? 3, 2 plus what? 2 plus 1 minus, if we integrate this, we are going to have our 4 into bracket x n, that is 1 plus what? 1 plus 1 all over what? 1 plus what? 1. All of this is with respect to x, and we'll have a constant. So this is going to give us, remember we are doing this within the limit of 2 and what? And 1. So this is going to give us our x what? Raised to power 3 all over what? 3 minus Hope you are following. This is going to give us 4x what square all over what 2 plus what plus c. This is the what the integration of this value with respect to the upper and the what the lower limit. That is not our solution. For we to solve further, we need to evaluate this further. Let's look at the upper limit and subtract it from the lower limit so as to get our proper integral value. So to do this, we are going to have our what? Our 2 raised to power 3 divided by what? 3 minus 4 into brackets 2 raised to power 2 all over what? 2. That is the first limit, minus the second limit. This is the upper limit. Now let's look at the lower limit. The lower limit, our value for x is 1. So that will give us what? 1 raised to power 3 all over 3 minus 4 raised to power brackets 4 raised to power bracket 1 square all over what? 2. That is our what? Our lower limit. So all we need to do is to simplify this so as to get our final what? Our final solution. Now to simplify this, we are just going to simplify. This is 2 raised to power 3. 2 raised to power 3 is 16. 2 times 2 4. 4 times 2. 2 times 2 is 4. 4 times 2 is 8. So that will give us 8. That will give us 8 divided by 3 in the first part. 8 divided by 3 minus 4. 2 times 2 is 4. 4 times 4 is 16. Minus 16 over what? Over 2. This is what for this. Then we'll go ahead to this. This will give us 1 over what? This will give us 1 over 3 minus what? 4 square. That will give us what? 4 over what? 4 over 2. This is for the lower limit. Done this, we can now reduce this to make the equation very easy for us to simplify. 2 here will give us 1. 2 here will give us that will give us 8, because 8 times 2 is 16. 2 here will give us 1. 2 here will give us 2. So we simplify it further. We'll have our 8 divided by 3 minus what? 8 divided by what? 1 for the upper limit. And then we'll go this way to do same for the what? For the lower limit. And that will give us what? 2 over what? 1. So when we simplify further, we are going to get this value. When we simplify further, this will give us 3. 3 divided by 3 is 1. 1 times 8 is 8 minus 3 divided by 3. 3 divided by 1 is 3. 3 times 8. 24. So we'll have our what? 24 here. Minus, we'll have 3 as our LCM here. 3 divided by 3 is 1. This will give us 1. Minus 3 divided by 3. 3 divided by 1 is 3. 3 times 2 is what? 6. So if we simplify this, we are going to have 8 minus 24, which is the negative side. So 8 minus 24 will give us 16, right? 8 minus 24 will give us 16. So we have 8 minus 24 will give us 16. So we have 16 over what? 3 minus this will give us, this will now give us, this minus this will give us what? Minus 5 over what? Over 3. So we are gradually breaking the bigger fractions into smaller fractions. So what we need to do now is to simplify further. So simplifying, we'll have our 16 over 3. This times this will give us plus what? 5 over what? Over 3. So we'll look for the LCM. The LCM is going to be 3. 3 divided by 3 will give us what? 1. 1 times 16 will give us 16 plus what? 16 plus sorry, this should be a negative sign, because 8 minus 24 is going to give you minus 16. That's an oversight. So minus 16, this will go with what? This will go with minus, and this will continue here, minus 16 plus what? This times this will give us what? 3 times 3 divided by 3 will give us 1. 1 times 5 will give us what? 5. So what do we have in general? Minus 16 plus what? Plus 5. Minus 16 plus 5 will give us minus 11 divided by what? By 3. So this is the solution to that integral question that was given to us. Remember, you were asked to integrate x squared minus 4x with respect to what? X. If you do that, and with the upper limit and the lower limits being 2 and 1 respectively, if you do that, this is the solution you are going to get. Now if you follow this step, you can use it to solve similar questions, remembering the general formula for integration. Now let's look at that final question we'll be taking for today. Remember, we'll be giving you 3 different questions. Let's look at the final one. Now let's look at the final question for this video edition, and the final question for this video on integration says evaluate the integral value of cos x with respect to x, giving the upper limit in radian, which is pi over 2, and the lower limit as what? Minus pi over 2. Now when you are given this question, all you need to know is to know the derivative of cos x. Now what is the derivative of cos x? Remember, I told you I'm going to give you all this integral derivative. Now the first time we looked for the derivative of sine of x, or sine of u, or the sine of u, which is minus cos u. Now the reverse is the case. If you are asked to look for the derivative, the integral derivative of cos x, is not going to give you a negative sign this time around. It's going to give you plus sine x. That is a positive sign plus the constant. Now if we integrate that value, now we are looking at the integral value with the upper limit and the lower limit as pi over 2 and pi minus pi over 2 respectively. Cos of what? Cos of x dx. This will now be equal to what? This will give us sine of what? Sine of x what? Plus what? C, with the what? Upper limit being pi over 2 and the lower limit being pi over what? Minus pi over 2. And this is not the result, because we are going to do this within this what? Within this limit. So that would now give us our what? Our sine of what? Within the limit of x, which is this. So that will give us sine of pi over 2 minus what? Sine of what? Minus pi over what? 2, considering the limit. So if we go ahead, we are going to have sine of what? Pi over what? 2 plus what? Sine of what? Pi over what? Pi over 2. Now remember the value of pi. This is in radian. It's more like an angle. Angles, degrees in radian. Degrees and radian. Now if you have angles written in radian, remember your pi is equal to what? 180. So half of pi is going to be what? 90 watts, 90 degree. This is when you're converting from your degree, from your radian to degree and to degree to radian. That will give us 90. So this, applying this here, we're going to have a sine of what? 90 degree plus what? Sine of what? 90 what degree. And sine 90 is 1. So we'll have our 1 plus what? 1. This will give us what? 2. So the integral value of what? This is what? Is just 2. Look at how monstrous the question looks like, but the solution is just as small as this. We can go. So the solution is just 2. Now these and the past 2 questions we've just treated are sections are the kind of questions you see when solving integration. Remember, I told you that I'm going to give you a full-blown video on integration. As you expect that video, I want you to learn from these 3 samples I've given you and the integral derivative I'm going to give you, so that with that you can be able to start solving questions as we look forward to the bigger video, which is going to be large enough to cover the whole topics in integration. I hope you learned a lot from this series of sample questions we've taken, and I know you've been watching the series of other videos we'll be producing. If you haven't subscribed to our channel, I want you to hit that subscribe button so that you can be able to get tutorial videos like this that can help you enhance your confidence in solving mathematics. You like this video, I want you to share to your friends so that they can also learn what you are learning. I look forward to seeing you watch our subsequent video. Aha, your bonus. Now you can check the screen for your bonus. You see the whole integral values, integral derivative of all the values we can integrate. I hope you are seeing them. As you do that, I want you to have a good time and see you some other time.